Hi, this is Will Durfee, and I'm going to give you a few pointers on how to do the mechanism assignment. And this one is the straight line mechanism. So I've opened up the mechanism on the screen, and then what I'll do is turn off all the axes to make it a little bit easier to see, and then I'm going to put it into a front view. Now I go up and drag components, and got the crank down here. We'll grab the crank and then spin it around just to make sure that the mechanism is all assembled correctly. Click and close that out. The next thing I'm going to do is to perform an analysis on this mechanism. So I go up to Applications and Mechanism, and then the Mechanism Analysis tool. Then I want to change the type from Position to Kinematic, and the end time to 12 seconds, and then keep the frame rate at 10. Then I'll hit Run. And it goes through about 1.5 cycles, and then click OK. Let's do a playback, and then click Run on the playback. And then with the animate bar, I can grab it and go frame by frame all the way around, or I can play it all the way around. And this is the one that if I wanted to, I can go and do a capture to create an animation. So we'll close that out. Then the next thing I want to do is to create a plot of the motion. For that, I'll click the Measures tool in order to create the plot. And you'll see in the Measures tool that the tip position X and position Y are already defined, and that's positions that are right up here in this little mark that's being highlighted up at the tip. If you have to create a new measure that you want to measure, you click on the new measure, and then the measure definition. So let's say we wanted to do another measure that was on the tip, but maybe on the other end of the hole, so right around there. So you'd click there, and then you can choose to have it be a magnitude or X component and Y component. The one that was already defined, it was set up to have an X component and then back to a Y component. So we're already good with the measure definition, so I'm going to cancel out of this because we'll just use the two that we have. Okay, so the first thing I want to do is measurement against time. The analysis definition 2 was that last run we did, the last analysis run. So we'll highlight that and then indicate that we want both X and Y as part of our measurements, and then click the graph. So now we've got a tool that shows the X tip as a function of time and the Y tip as a function of time. Let's close out this measure results, and then go back to the mechanism tab and hit playback, and then play again. And now I've got a tool where I can play it through frame by frame and watch the mechanism, and then you'll see on the chart that red bar shows where we are in the mechanism. And you can see from here, let me move this a little out of the way so you can see the mechanism. From this position all the way through to about this position, the Y-axis of the tip is not changing very much. That's the straight line part, and it goes up and around and then finishes off its straight line, the right-hand side, in this part of it. And you have to remember that this is cycling around 1.5 times. So that's how you create a chart. Let's go back. We'll close out that chart, close out the animate tool, close out the playlist tool, and then go back to the measures. And now we'll select a measure versus measure. And on the x-axis, we'll keep it as the X position, and then this is that same run. And on the y-axis, we're going to do the Y position of the tip. So let's create a graph of that and then close out our measure results and take a look at the chart that we have now. So this chart plots Y tip versus the X tip, and you can clearly see that along this whole range of X, the Y is changing by not very much, just a few millimeters. And you can go ahead and click here to download to an Excel file so you can get these data points and examine them and do whatever analysis that you want. Now I'll show you how to do a mechanism redesign. Let's say that we wanted to change some of the link lengths. There's a couple of different ways of doing it. One way is directly from the assembly to change the underlying part. So for example, this link A, which is the crank, is now 40 millimeters. I'm going to go ahead and change it to 20 millimeters. So if you look over on the model tree on the left, that's that link A part. If you click the edit definition, that doesn't tell you how to change the link itself, but rather how to change how it's assembled and the assembly constraints. So we don't want to do that. What I can do is open up the link part and get down to the extrude. That's the was a fundamental operation to create the link. And then if I click on that, I've got some options, including one that shows the dimensions or edits the dimensions. If I click on that, then all of the key dimensions show up. So I can double click on the 40, which is the distance between the center of the two holes where the pivots are, and change that to 20. You haven't seen the change on the screen yet because you do have to regenerate the part after you make changes like this. I'm going to regenerate by doing Control G. Now my crank length has changed from 40 to 20, so I can use the Drag Components tool and see what that looks like. So that's got the tip traveling in a different way. And this won't be a straight line mechanism, because for a straight line mechanism, each one of these 1, 2, 3, 4 links have to be in a particular proportion to each other to keep that straight line. So I've only changed link A, and I'd have to go ahead and change the other links. Now, the method that I just described can have some limitations, because if you change a link, and for example, now it can no longer achieve the constraints, because if you made, say, the distance between this on the B link, the distance between this hole and this hole so long that this link could no longer assemble to it, then when you try to make that change, it's going to give you an error message. So generally you can make the changes you want by thinking carefully about the order that you make the changes. There's another way though that I'll show you, which is to start from the basic parts themselves and change those. So now I'm going to change it by editing the parts directly. So for that, I open up that link A part. And now here's that link, and now I can go in, just as I did before, to the extrude, and then change. What I think I'm going to do is, because I'm going to make a completely new assembly, I think what I'll do first is go to File, and then Save As, and then save a copy, and then I'll call this link A02 for this second link A part, and click OK. Then I'm going to go ahead, let's close out this because I'm still in link A, and then open up, and there's my link A02 part. So let's open that up. Okay, so now for that, and I just checked that I have the right part, link A02. Now go to the extrude, click on the extrude, again get edit the dimensions. From here, 40, I go down to 20, click OK, and then click regenerate, and now I've got a new link That's 20. Now that I've got the new link, let me take you through how you'd assemble it into a new mechanism. And let's say I've changed all the links, which I haven't. And then you want to create an entirely new mechanism. So along the way, I'll show you how to assemble a mechanism like this. So we'll do a new assembly, and we'll call it Straight Line 02. And click OK. And then I'm just going to start off enabling the plane displays. So we assemble, and then the ground link is link D, so we'll call that in. And then because it's the ground link, we'll just go ahead and do that as a default to anchor it down to the datum planes, and then click OK. Now I'm going to turn off the plane displays. Then the next link would be link A. So we'll assemble link A. We'll take our new link A in this case and click Open. And now our link A appears. So we're going to go ahead and do that with a, rather than a user defined, with a pin constraint. On that pin constraint, the first thing you have to do is to tell it the two axes is going to rotate around. So you can do that by defining the inside surface of the hole. So I pick the inside surface on link A, and then the inside surface on link D, and that says that now this pin is going to rotate about that hole. The other thing we have to tell it is where it is in this direction with the other link, and we want it to be on the back side of the other link. One thing you have to think about in these mechanisms is how to arrange the placement in the order of the links so they don't clash into each other when you spin things around. Okay, so we want this surface to be coincident with the back side of link D. Now we're all set, sitting around that link. It's a pin constraint, and we can click OK. And you can go ahead and assemble the B link and the C link the same way, again with pin constraints. I'm going to put in the actual pin part now to show you how that works. So again, we'll hit Assemble, and this is the pin part. Open that up. And this is a decorative part, so we're not going to be assembling it using a pin mechanism, but rather just putting it right in with a couple of coincident constraints. So I'm going to pick the surface of the pin and then the inside surface of the hole. So that gets it all lined up that way. And then I just have to get the in and out part right. And for these kinds of manipulations, it's convenient to turn off the spin center. When you have the spin center on, then when you spin, it spins it about the whole mechanism. So here we want to look at spinning just around the pin and then just around the mechanism. So I'm going to go ahead and turn the spin center off. Then I can spin just about the pin, and I can click the undersurface of the head, and then go back and click the top surface of link D, and then we've got that pin nicely situated inside, and then click OK, and then I can go back and do the drag components, just make sure everything's okay, and we're good to go. So that's how you can assemble the mechanism after you put in the other two links for whatever dimensions that you want. That concludes the tutorial on the straight line mechanism, and I encourage you to go and design linkage shapes of your own, move them around with the drag components, use the measurement and analysis tools and mechanisms to see how they would move, and perhaps you'll find a 4-bar linkage, perhaps a straight line linkage that will be useful in your robots.